I'm Mr. Kangas, and today we're going to be taking a look at Chapter 9, Section 5, the distance formula. And in this lesson in particular, we are going to be taking a look at what the distance formula is and how do you use it. So the distance formula looks a little complicated, but really isn't that bad. So what is going on here? You're going to want to write this down if you're one of my students. Take notes on it so you can hopefully retain this. And I will also have a video. The video after this will explain to you that distance formula actually is just a form of Pythagorean theorem, and we'll talk about that, and we'll show you the comparison and how this is actually just a form of Pythagorean theorem. So, now if you've done this chapter 7 on slope, you should recognize the y1 minus y2 and the x1 minus x2. So the really distance formula, it kind of takes in a couple of pieces. It's got some pieces from chapter 7, but it also has a lot of Pythagorean theorem in it as well. And we'll tie all that in a different video. But basically what distance formula is used for is, more specifically than Pythagorean theorem, distance formula is used for information from a coordinate grid. If you want to find the distance between 2 points on a coordinate grid, that's when we're going to use the distance formula, whereas Pythagorean theorem was used when you were given side lengths of a right triangle. Now, right triangles still have something to do with this, but again, we'll talk about that in a different video. Right now, I'm just going to show you the basics. How do I take this really complicated looking formula and use it to find the distance between 2 points? Well, first of all, I'm going to tell you this. It looks complicated, but it's not as complicated as it sounds. It's just going to require a lot of work or effort or time on your part. There's a big difference between something being hard and something requiring a lot of time. This is going to require a lot of time to solve. The hard part might be memorizing this formula. That could take some time, and that could be a little difficult for some of us. But that aside, using the formula should be pretty simple. So here we go. What you need to have in order to use this formula, if you haven't caught on yet with the x1s and the y1s and the x2s and the y2s, you need to have the coordinates of 2 points. So if I have, for example, coordinates of 3, 5, and I have coordinates of, we'll go with 8, we'll go with 8, 6. Okay, 3, 5, and 8, 6. Okay, I know that the 2 points I'm looking at have these coordinates, and I want to know how much distance is between these 2 points. I'm going to pick one ordered pair to represent my 1s and one ordered pair to represent my 2s. Doesn't matter which one you choose. Okay. So I'll just choose the top one to be my 1. So in place of my 1s, my y is going to be a 5. x1 is going to be a 3 because here's my x coordinates, here's my y coordinates. The y is a 5, the 3 is an x. Okay? x1 and y1 come from the same ordered pair. x2 and y2 come from the same ordered pair. So, put those over here. The 8 is my x, 6 is my y. Can't forget the little squares up here, because I'm going to have to square this information here in a minute. 5 minus 6, negative 1 squared. 3 minus 8, negative 5 squared. Okay. So at this point, I need to square what's inside. Negative 1 squared is 1. Negative 5 squared is 25. Add these together. 1 plus 25 is, because I'm running out of room, I'm just going to erase this. 1 plus 25 is 26. And so to finish the distance formula, I would take the square root of 26, which is about 5. It's not exactly 5, it is about 5. You get 5 point something if you do it out and get the exact answer. So the distance between these 2 points is about 5. Now, if you have a calculator available, or if I tell you to use calculators or to find the exact square root, I would expect you to use a calculator and give me the exact number. You would tell me 5.2 or something like that. But the distance between these 2 points would be about 5, because the square root of 26 is about 5. So really that's all there is to it. I'll do one more example just to kind of walk you through the process again. Some people like to have more than one example. If you feel like you get it, you can turn the video off at this point, but only if you're 100% that you get how to use the formula. So again, we're going to put the formula up. y1 minus y2 plus x1 minus x2 all squared. Okay, so I'm going to use the 2 points. We'll go with 6, 10, and we'll go with the 4, 1. Okay, so I'm going to choose an ordered pair to represent my ones. I'm going to choose the top one again, just for consistency's sake. So in place of y1, I will put 10, because again, here's my y coordinates, here's my x coordinates, right? In place of x1, I'm going to put 6. Okay, the ones come from the same ordered pair, 10 and 6. Okay, y2, x2. Okay, very, very, very important that you get those in the right place. Right? You get 9 squared plus 6 minus 4 is 2 squared. Square both of those numbers. You have 81 plus 4. 81 plus 4 is 85. So the square root of 85 would be the distance between these 2 points, which is a little bit more than 9, because the square root of 85 is going to be 9.3 or 9.4, somewhere around there. Not exactly, but it's going to be about 9. So again, that's the distance formula. It finds you the distance between these 2 points I've listed up here on the board. Okay, now sometimes you may be given just a graph that has 2 points on it. If that's the case, you need to find the ordered pairs that go with the points and then plug them in. Okay, so that's all there is for this video. The next video, we're going to talk about how does slope and how does the Pythagorean theorem relate to the distance formula.